In the world of highway transportation, safety continues to be a major concern. One area deserving further attention is bridge railings and their transitions to approach guardrails. The structural and geometric design requirements for bridge railings defined in the AASHTO Bridge Design Specifications are intended to provide properly performing bridge rails. However, the real test of railing performance comes from observing the results of vehicle impacts. Crash tests verify if a railing will contain and smoothly redirect vehicles. For this reason, it is important that all railing designs be crash tested. Today, there are over 160 types of bridge rails in use in this country. Only a small portion of these has been crash tested. Several railings believed by their designers to meet the AASHTO bridge railing specifications have performed poorly when subjected to admittedly severe but realistic crash tests. Let's look at some examples. Several design problems with this bridge railing system, including its open face that allowed the car's bumper to snag on a post, led to this dramatic failure. In this example, the curb forced the wheel upward and caused it to snag on a post, resulting in this rollover. When the concrete rail and post were torn apart by impact on one side of this joint, the still intact rail and post on the other side of the joint were left exposed. The resulting snagging caused the tearing away of the passenger side of the test car. In this example, hood snagging in the crash test revealed an unexpected problem with this railing, which has not occurred in a two-rail version of the railing. Another important concern is the proper performance of guardrail bridge rail transitions. A W-beam guardrail is typically used on the approaches to bridges. Transitioning from this relatively flexible barrier to a rigid bridge railing is a difficult design problem. With its reduced post spacing of 3 feet 1.5 inches and with secure rail attachment to the face of the parapet, this common transition fails to solve the problem. Deflection in the W-beam allowed the front of the car to hit the end of the parapet. The structural adequacy of the elements of a railing is essential, but far from sufficient to ensure proper performance. The elements must work together as a system and interact with a wide range in vehicle types, shapes, and weights. Crash testing has shown that in addition to providing adequate height and strength, safe railings must prevent snagging. Also, railings must provide structural continuity, and they must provide gradual changes in flexibility where necessary. Here are examples of some railings that meet these requirements. Remember the concrete railing system that tore off the side of the car? After this test, a modified design was developed. Although identical in outward appearance, the railing has been substantially strengthened by adding reinforcement to the posts. The modified railing smoothly redirected the test car. One state recently developed this see-through collapsing ring bridge railing. Note that the broad lower rail provides a good contact surface for both bumpers and wheels. The rail is also blocked out with pipe sections that crush and absorb energy. And when crash tested, the car is properly redirected. Another successful system is this tubular thri-beam rail. Note that the deep rail face practically eliminates the potential for vehicle snagging. In this design, the 39-inch high combination concrete safety shape and aluminum rail smoothly redirects the test vehicle. This railing has also successfully redirected a 40,000-pound bus. Improved transition designs have also been crash tested. This retrofit design was developed for the transition viewed earlier. Key modifications: a second W-beam was nested inside of the upper rail and 2 posts were added. They are the darker color posts in the picture. These changes help to gradually stiffen the transition as it nears the parapet end. Also, A W-beam rub rail was added to reduce the chance of wheel snagging. This retrofit, at a modest cost, greatly improves the performance of this transition. Other good transition designs are available. For example, this particular design connects a W-beam guardrail through a tri-beam transition into a flared vertical wall. Note that a crushable pipe blockout is used to absorb energy and help smooth the transition. The result? This car is smoothly redirected.
I hope what you have just seen has convinced you of the desirability of using bridge railings and approach transitions that have been successfully crash tested. I know I'm convinced. To promote the use of test-proven railings, we in Federal Highway Administration have assembled information on 22 bridge railing designs that have demonstrated successful performance when crash tested. This information has recently been forwarded to our field offices, along with instructions that only proven crash-worthy railings be used on federal aid projects. To help promote better bridge rail transition designs, we are now preparing a technical advisory to disseminate results of the crash testing program on transitions. You probably already know that AASHTO and FHWA are developing an updated roadside design guide. As part of this effort, a new bridge railing specification is being prepared. Within the near future, a new railing specification containing 2 features will be out. There will be a requirement for crash testing bridge railings. And second, there will be a recognition of multiple performance levels in railing design and selection. In support of this effort, FHWA is managing a multi-state funded research project under which various bridge railings and transitions will be crash tested. It is anticipated that existing designs as well as new designs will be tested. 19 states have already joined us in this effort. Others are most welcome. If you are not participating and you are interested in joining, or you want further information on the research, please contact your local FHWA division office. In closing, the thought I want to leave you with is that the proof of a good design is proper performance under actual crash conditions. There are bridge railings and approach transitions that have been successfully crash tested. We should be using railing systems on our nation's highways that are proven safe. We owe it to the traveling public.